This is an introductory video for Physics 1050, lab number 3, force and acceleration. In this experiment, we're going to use a track as an inclined plane. We're going to measure the motion of a cart sliding down the plane. From our measurements of motion, we're going to find the acceleration of the cart as a function of the angle. Using this data, we're going to calculate the magnitude of the acceleration due to gravity. So there's our objective of the lab. For our apparatus, we're going to have a cart, a Lab Pro, a motion sensor with its cord, a digital inclinometer. We're going to use this device for measuring the angle. We'll have a dynamic cart. For this one, make sure you just turn it upside down when you're not using it. We'll have a rod and a clamp. We'll have a plastic reflector card, and we'll use some masking tape. So those are the apparatus we have. Let's start to assemble our apparatus. We'll put the sheet rod into the desktop. This is what we're going to raise the track up and down on. Then we want to use our clamp to attach the track to the rod. So the first thing we can do is we can loosen up this wing bolt here with the nut. Loosen that up a bit until we see some space right here. Then we're going to take this square nut and slide it into the ridge on the track. So we'll slide it right in there. We'll tighten that up a bit. And then with the hole in that clamp, I'm going to slide that over the rod. We're going to screw that on there tightly, tighten up the wing nut, make sure our track is straight. Okay, now we're all set up for our first run. So by lifting and lowering this, we can change the height of the track, which means we'll change the angle. To measure the angle, you'll need this for filling in one of your tables. You take your digital inclinometer, you see it has 3 buttons. We'll only press the on-off button. Don't press the hold button, and don't press the 0 button. It's already zeroed. So we'll turn it on, we'll lay it on the track, and this is going to tell us our angle. So for example, mine reads 7.90 degrees. So that's how we get our angle. We're going to measure the motion of the cart as a function of time. We'll use the motion sensor. That needs to be plugged into the Lab Pro. So we'll untangle our cord. We'll plug one end of the cord into the motion sensor, plugs into DigSonic. And we'll plug the other end into the Lab Pro. We'll look for the ports labeled DigSonic. This is the first device, so we'll plug it into port 1. Okay, all set up. Our motion detector is going to go on the top of our track. When you lay it there, you might notice it starts to slide. We don't want it to slide around, so let's hold it in place. You can try and come up with some creative methods. My method is just going to be a piece of tape. When you secure it in place, one thing to watch for is the gold foil circle here should be in the middle of the track, because that's the part that sends out and receives the signal. Okay, now we need to get the cart ready for measuring. We're going to put the plastic reflector card on one end of the cart. You'll notice that your card has a wide end and a narrow end. We want the narrow end to face like this so it covers the cart, but it doesn't go over the edges. And then notice, we don't want the card to go down over the bottom of the cart. We want it to be just above. That's because we don't want to have any friction with the track. Okay, so make sure you have a couple of millimeters between the bottom of the card and the bottom of the cart. We can hold that in place with some tape as well. We don't want this to wiggle around as we do our measurements, so make sure your card is held in place nice and securely. We'll do our best here. All right, so now we're all set up. We're ready to take our measurements. Let's go ahead to the place where we'll open Logger Pro. So we'll scroll forward in our PDF. We'll click the button. We'll say yes, we really would like to open it. Logger Pro will open with 2 graphs for us, position versus time and velocity versus time. And let's see how we're going to do our first trial. So you'll be working in partners. One person will hold the card at the top. The other person is going to press collect, and then the person that's holding the cart, this is really important, has to be ready to catch the cart at the bottom. If the cart comes down and falls off, we could damage them. They're difficult to repair and expensive to replace, so please be extra sure that you're catching your carts. Okay, let's give it a try. I'll press collect. hear it clicking. I'm gonna let it go and I'm gonna catch it. After 3 seconds, the collection will just stop by itself. I'm gonna look at my data and ask if I'm happy with it. So I have this still bit right here. This is where I'm holding the card still. I have this curve. This is where it's rolling down the track with a constant acceleration, so I get a curved track. And I have this bit right here. Again, it's constant. That's where I've caught it with my hand and it's holding still. So my data looks like I expect it to. To do my analysis, I'd like to find my acceleration. I can find my acceleration from the graph of velocity versus time because I know acceleration is the slope of velocity versus time. So for that analysis, maybe you remember this from a previous lab. It'll just take us a moment, so let's go through it. We have to carefully think about our velocity data and select the part that looks like a straight line graph. This is the part where it had constant acceleration. Now that we've highlighted that part, we'll go to Analyze, choose Linear Fit. When I choose Linear Fit, that tells us the slope of the graph. I'm just going to make that font bigger so it's easier to see. So here's the slope of the graph. You see it has units of meters divided by seconds divided by seconds. That's meters per second squared. This is our acceleration. So in your table of data, you're going to need to record your slope, your acceleration, your angle, and you'll calculate the sine of the angle as well. That'll also be in your table. In the next video, we'll talk about how to do the analysis to figure out G.